Hi, I'm Mr. Strang, and I have a question for you. What does this dragon, this notepad, and this gas can all have in common? Well, yes, they're great for starting fires, but besides that, they're all made out of stuff. This is paper stuff, we got dragon stuff, we even got 3D glasses stuff. But what is stuff anyway? What is our universe actually made out of? Let's find out. Oh, hi. I didn't see you there. I was just catching up on some reading. You know, this book is made out of stuff, just like the glasses and eyes I'm using to read it, and the brain I'm using to interpret it with. But what is that stuff? Well, if we take this book and we were to cut it down to its itsy bitsy smallest pieces, we would actually come across the basic units that form matter. And those basic units are called atoms. An atom is the smallest unit of matter that has the properties of a chemical element. There are carbon atoms, nitrogen atoms, oxygen atoms, all sorts of atoms. And they're the smallest single unit that makes up, well, everything. So if atoms are the smallest unit, what makes up atoms? Well, nothing, right? I just told you they're the smallest unit. What could make up something smaller than the smallest unit? Nothing, right? Wrong. Science is weird. Get ready. Let's take a look at this picture again. As you can see, there are 3 different colored circles that are found inside this atom. These actually make up the 3 subatomic particles of the atom. They're called protons, neutrons, and electrons, and they each have their own unique properties. Let's start with protons and neutrons. Protons and neutrons make up what we call the nucleus of the atom. Most of an atom's mass is contained inside this nucleus. Protons, which are represented by red circles in this diagram, are designated as having a positive charge. Besides being assigned a positive charge, protons also serve a very important role in identifying chemical elements. If you change the number of protons in an atom, you change the chemical properties of that atom, because then it becomes a different element. Carbon atoms will always have 6 protons, oxygen atoms will always have 8, hydrogen will always have 1, and so on and so forth. When you change the number of protons in an atom, you change what the atom actually is. The term we use to identify the number of protons each element has is called its atomic number, which you can see here. Every element has a different atomic number, because when you change the number of protons in an atom, you change the element itself. Protons, you'll remember, are located in the nucleus with another subatomic particle. That other particle is called the neutron. Unlike a proton, a neutron is actually neutral in charge, meaning it doesn't have a charge. Unlike protons, the number of neutrons in an atom can actually change. When atoms of the same element have different numbers of neutrons, we call these variations isotopes. Isotopes refer to any atoms of the same element that have different numbers of neutrons. Let's look at the element carbon as an example. Carbon has 3 well-known isotopes: carbon-12, carbon-13, and carbon-14. Now, you may think that 12, 13, and 14 would refer to the number of neutrons. Actually, it refers to the total number of protons and neutrons. Carbon-12 has 6 protons and 6 neutrons, carbon-13 has 6 protons and 7 neutrons, and carbon-14 has 6 protons and 8 neutrons. Now remember, carbon will always have 6 protons. So the variation between the different isotopes is really how many neutrons each carbon atom has. So why do we even care about isotopes and neutrons anyway? I mean, they don't have a charge, they don't change an element like a proton will, so what's the big deal? Well, actually, different isotopes can provide us with a lot of different information. Isotopes are used in medical imaging, they can be used to date certain fossils, and they're used in all sorts of different kinds of scientific research. So even though it's just one difference of one particle, isotopes provide us with a lot of information. Okay, so we've talked about what's in the center of the atom. Protons and neutrons work together in the nucleus, and they make up the majority of the mass of the atom. Protons are positively charged and neutrons are neutral. Okay, fine. But we still have one subatomic particle that we haven't discussed yet, the electron. What's its story? What is it doing? Well, actually, the electron is so important that we're going to dedicate pretty much the entire next episode to what the electron is and what it does. But for now, let's just talk about some basic characteristics. The electron is by far the smallest and least massive of the subatomic particles. In fact, any single proton or neutron is almost 2,000 times bigger than an electron. These things are really, really tiny, even on the scale of super tiny things. We designate the electron as having a negative charge, meaning it's the opposite of a proton. The size, location, and charge of the electron are very important. Those characteristics determine how the electron interacts with its surrounding atoms. How does it interact with other atoms? Well, that's what we're going to talk about next time. But let's go ahead and review what we've talked about so far. Today, we talked about what stuff is made out of. We learned that every bit of matter is made from something called atoms, and that atoms are made up of three subatomic particles: protons, neutrons, and electrons. We learned that protons and neutrons are located in the center of the atom called the nucleus. We also learned that protons are positively charged and neutrons are neutral. We learned that neutrons can vary by their number in the atom, and that these variations are called isotopes. Different isotopes can provide us with different kinds of information. And finally, we learned that electrons, which are much smaller and negatively charged, surround the outside of the atom and are involved with how atoms interact with one another. Thank you so much for watching, and thank you to everyone who supported the production of this video and the Strang Theory project. If you found this video useful, informative, or interesting in any way, feel free to like and subscribe. If you have any ideas or questions you'd like to share, go ahead and leave a comment below. Thanks again, and I hope to see you next time. Have fun, study hard, and learn well.